अब हम बात करेंगे प्रोसीजर की बायोरेट एसे की। जैसा कि मैंने पहले भी आपसे शेयर किया कि वॉल्यूम जो है सैंपल की और रीएजेंट्स की हम इंक्रीज़ या डिक्रीज़ कर सकते हैं ऑन द बेसिस ऑफ अवेलेबिलिटी ऑफ द ग्लासवेयर ट्यूब्स और रीएजेंट्स वट एवर द सप्लाइज आर रिक्वायर्ड। उनको सामने रखते हुए हम अपने पास जो एक्सपेरिमेंटल सेटअप है उसकी वॉल्यूम्स को एडजस्ट कर सकते हैं टू परफॉर्म दिस essay. As we have to use spectrophotometer towards the end of this essay, it is always recommended that pre-warm the spectrophotometer. अब स्पेक्ट्रोफोटोमीटर को 15 मिनट पहले स्विच ऑन करना मैंडेटरी है ताकि उसकी जो एब्जॉर्बेंस वैल्यू है दैट शुड बी द एक्चुअल वैल्यू, अदरवाइज there should be some problems in the absorbance values which are given by any spectrophotometer which is just switched on as you are going to use it. दूसरे नंबर पे जब हम बात करते हैं unknown samples की, if we have to determine the protein concentration in unknown sample, we need a standard curve or a known standard values of graph from where we can compare the values. For that purpose, अभी हम बात करेंगे how to prepare the standard curve and at the same time how to determine the concentration of unknown samples using that standard curve. अगर इस टेबल को देखें, ये टेबल आपको ट्यूब नंबर्स के हवाले से शो कर रहा है, नंबर 1 to 7. These are different tubes which are going to have different concentrations or volumes or amounts of known standards, that is BSA, bovine serum albumin. हमने यहाँ पे वाटर की different concentrations volumes यूज़ की हैं. If you look at this, the total volume is 1 milliliter in every case. But as we proceed further, we decrease the volume of water and we added the volume of known standard, that is bovine serum albumin. And then this mixture is going to be used for the assay to prepare the standard curve, and that standard curve will be used to determine the concentration of unknown sample. अब इसको हम कैसे proceed करते हैं? Let's see here. These 7 tubes, they contain the standard BSA with known volume, whereas 2 other tubes have the sample with unknown concentration, and these are the samples which we have to determine the concentration. Once we prepare these dilutions, we are going to add 2 milliliter of biuret reagent. मैं यहाँ पे एक दफ़ा फिर बताता चलूँ, ये 2 ml volume adjustable है. It can be increased up to 10 milliliter depending upon our initial volume of the sample. So in this case, we are going to add 2 milliliter of the biuret reagent, and then we have to mix the biuret reagent and our sample so as the reagent and the sample can easily be mixed up. Maximum peptide bond should be exposed to the copper which is present in the biuret reagent, and for that purpose we do the vertex immediately for thorough mixing, and then we leave these tubes for 15 minutes at room temperature. Mixing immediately is mandatory. After that, leave for 15 minutes so that the color development can be seen, and then the absorbance is read at 550 nanometer. Once we are ready to observe the intensity of color or absorbance, for that purpose we proceed further and we get the optical densities. Those optical densities are going to be plotted against the known concentration of the standards. जो 7 ट्यूब्स हमने प्रिपेयर की थी जिसमें हमने BSA डाला था स्टैंडर्ड as a standard 0.1, 0.2, 0.3 and up to 0.6 milliliter, that gave us the known concentration and known optical density. Those points were used here to plot a standard curve, and then this standard curve or these points were used to draw a regression line. Regression line can easily be drawn using the Excel software. That regression line, if the concentration is best, if the optical density is okay, there is no error because of the spectrophotometer or because of any contamination, any unwanted material in the tubes, then you get the best fitted line. And how best fitted line is that can be seen by the value of r square. This is the regression equation, and the r square value is automatically calculated. If r square value is 1, it means your absorbance, your line is absolutely right and it can be used. The more it is away from 1, the more problems can be predicted in your absorbance values. So you have to go back and you have to do this standard curve preparation once again. अब हमारे पास दो किस्म के स्पेक्ट्रोफोटोमीटर्स इस वक्त एग्जिस्ट करते हैं, एक बेसिक स्पेक्ट्रोफोटोमीटर और एक लेटेस्ट स्पेक्ट्रोफोटोमीटर जिसमें हमने कंप्यूटराइज सेटअप और इंस्टॉलेशन कर दी है. In those systems we can make this standard curve once, and then we can use this standard curve as a reference for every time we want to see the concentration of proteins. And in that case we don't get the optical density, we get directly the concentration of protein per milliliter or per microliter of the sample. जो conventional या simple spectrophotometer हैं, when we go to those, we have to have this standard curve, and then we can take the optical densities from there, and then we can read the concentration from this particular standard curve. इसमें एक और चीज़ का ख्याल रखना ज़रूरी होता है कि इंक्यूबेशन टाइम जो हमने अभी बात की कि 15 मिनट के लिए इसको रूम टेम्परेचर पे छोड़ दीजिए, 10 मिनट के लिए इसको रूम टेम्परेचर पे छोड़ दीजिए. टाइम शुड बी 10 to 15 मिनट्स. इसको इससे ज़्यादा प्रोलॉन्ग करने से कलर इंटेंसिटी वेरी करती रहती है, और उसके बाद जो रिजल्ट्स हैं they could not be reliable because of any kind of error that comes in that particular tubes. This assay is not reliable for any sample which has less concentration, less than 0.5 milligram per milliliter. So overall, if we look at this complete assay, the more is the protein, more peptide bonds are present, more copper is going to make the chelated complexes, and then more color is developed. And if we look at the tubes, we will have some negative result. Nothing is present, no protein is present. We normally establish, or we normally use one negative control whenever we make the standard curve, so that we see that there is no error or no contamination. This tube shows the negative result. That means no BSA was added, no protein is present in this particular sample. And if we look at the intensities of all these tubes, the gradually increasing intensities of the color means the concentration of protein is gradually increasing. So this color change is an indication of presence of protein in the given sample.